Hello, good morning, everyone.
Hello.
Um, Welcome to this next coffee break with Eddyfi. My name's Paul Jackson, and I'm the Director for the Centres of Excellence for MFL, NDT Robotics, and Guided Waves. And today we're going to talk about proposed solutions for corrosion under pipe supports. This is widely acknowledged to be a significant challenge for the pipeline industry. And today, myself and my colleague Gareth Mugford, who's the product manager for NDT Robotics, will talk about two solutions that we have within the Eddyfi technology portfolio. So what I'm going to do is just start off by talking about, a reminder of the basic designs for pipe supports, and then we'll talk about the phased array and a guided wave using medium range ultrasonic solutions. So Gareth's going to talk about the phased array option, and I'll talk in a bit more detail later about the medium range option. So in terms of pipe supports, there are two main types. You've got the simple or welded type pipe supports. On the simple type supports, you've got the resting. Commonly, these are just on a simple I-beam, or you've got the clamped pipe supports as well. In terms of the welded pipe supports, you've got, again, sort of a few main types. Often the pipes can be have upright supports where there's if you like, a weld running along the base of the pipe. This could be a single upright or it could be a double upright. And you've also got more sort of complicated welded saddle type supports as well. And each one of these, different types of pipe supports requires a different type of inspection strategy, and it's dependent on several factors. For example, access. How easy is the pipe support to access? What is the pipe support geometry, as I've discussed previously? What is the pipe diameter? Is it very small? Is it very large? And what the end user requirements are as well. Do they require a minimum remaining size, or would they be happy with some kind of screening? So Eddyfi's got two types of techniques that are quite complementary to each other. The first one is phased array, either using a link scanner or using an RMS, and the second option would be to use medium range ultrasonic testing. So first of all, Gareth is going to talk to you in a bit more detail about the phased array options that we have within Eddyfi. So Gareth.
Thank you. Cheers, Paul. Yeah. So as Paul mentioned, the number of pipe supports that we've got to come up against, and the two disciplines that I'll speak to you about today consider a pitch catch method. So you need access to both sides of the pipe support, those sort of solutions where we look at pitch catch phased array. Or a pitch catch conventional method like MSkip. Um, Specifically on MSkip, it's a recommended practice. Generally used for thicknesses 9 millimeters and above, and pitch catch phased array for around 6 millimeters and above. But both got places in the market, and we've got obviously solution packages that can come together to be able to deploy those applications. So we recently added to and built upon our link scanner. So for those of you who don't know the link scanner, it's a manually encoded scanning system, high utilization and reconfigurable for multiple applications. So base level, we're talking phased array weld inspection, Toft weld inspection, phased array corrosion mapping. But the complex pack that we've introduced now allows for cups, so corrosion under pipe supports, through like a adaptation of the system, so that we can run over the top of a pipe. So where you've got a pipe sat in a support itself, you'd introduce the complex pack, a number of hinges and extra rails, so you can position the wedges either side of the pipe support and traverse axially over the pipe support to provide you with quantitative remaining wall thickness measurements. But then also that complex pack can be reconfigured to allow you to travel circumferentially, where you'd set up the probes either side of the pipe support, and again provide new quantitative data sets.
I think we have a couple of photos that might be able to illustrate that.
Yeah, so in the slide that you can see there on the top left, that's our axial scan information of the links. So it travels longitudinally down the pipe, and you can actually extend now the arms of that setup with the complex pack, so that you can position yourself running over the top of the support. In the top right is another means of collecting that data, and I'd say that the complex pack is for your sort of small diameter pipe ranges, up to the sort of medium diameter pipe ranges. And then when you move into the medium range, we can set up like a dual chain arrangement, as you can see in the top right. Keeping probe alignment is key for pitch catch methods. And we can traverse around the circumference, interrogating those blind spot areas behind the obstruction. And in the bottom right, we've also got automated deployment through the RMS. So the RMS itself is traditionally a corrosion mapping, automated corrosion mapping remote solution. But again, recently we've added weld inspection capability, and we've also got the ability to reconfigure that into for a cups arrangement. We do this by removing the scanner drive enclosure, which is like the brain of the scanner. We've repackaged that into a magnetic box, which can sit above the pipe support, and we promote this use on the larger diameter pipework and pressure vessels. And again, as alignment is key, there's the specific tools in the feature set of the software to be able to nudge those tractors, so you can find the maximum amplitude signal for that probe alignment. And then of course you've got our scanning patterns, so that we can move them in sync with each other. Coming back to the sort of complex pack that you can see in the top left, it's as well as cups, it's also good for flange joint inspection, HDP collars, and it's very much just to give the user that that configuration and flexibility to perform complex inspections as best as you can. Where we come like sort of and look at MSkip technology. So it's a conventional like sort of pitch catch method, the traditional MSkip, and the basically through triangulation and the deployment of the pitch catch method, you're able to interrogate the behind the obstruction and provide quantitative wall thickness measurements through the multi-skip technology. So the reason it's able to detect defects is you'll get a reduction of arrival time of the transmitting signal. And as that's moved on, there's as well as traditional MSkip and having a strong place in the market. There's also pitch catch phased array methods. This is what you can actually see on the images, where we've positioned phased array probes in a pitch catch formation, and when we're set up with two sectorial beams, we're able to collect those data sets and pass them into third-party software packages, which have built-in algorithms to provide you the integrity sort of assessment of the obstructions that you come up against. I know this coffee break is predominantly about cups, but also like another place in the market is for these types of techniques and scanners is for corrosion scabs. So where we look at corrosion scabs with any sort of fabric maintenance program, there's often that discussion of is it safe to blast off? How much remaining wall? Is there any degradation underneath that corrosion scab itself? So for many years, the fabric maintenance guys are looking for that level of confidence, to make sure that they're not putting their guys at risk of blasting like a high pressure line with a hole behind it. So you could deploy these pitch catch methods either side of the corrosion scabs to give you that confidence, where you're able to get that quantifiable data set, so that you can give a go no go scenario for that fabric maintenance program. I don't know if you want to move on to the Sonics portion now, Paul, and then we'll pick up any sort of questions at the end, if anyone wanted more information on that on those disciplines.
Well, there's we did some field trials. If you can move on to the next slide, there was some field trials data that we've got, I believe, here, where we compared the different third-party methods, and you can see, relative to the data that we collected, we got good correlation between the defect and the minimum remaining wall thickness there compared to the actual sample. So it sort of gives us really good confidence about, the equipment and these methods as being really good and valid, for this type of applications going forward. And certainly when I was watching the method, I was very surprised at how quick and easy the methods were. And once you got the setup done, you were able to then move between the locations pretty quickly. But yeah, moving on to the medium range. So if you move on to the next slide, just to show, obviously we recently launched the Sonics instrument, and this instrument allows us to do so much more. And what we're really excited by is the results we're getting from the high frequency magneto tools. So this is looking at 128 kilohertz, where we're still using guided waves, but rather than using guided waves in what we call the long range ultrasonic mode, we're more using it because it's above 100 kilohertz in the medium range ultrasonic mode. And by increasing that frequency, it gives us a really significant improvement in sensitivity. And it's still an axial inspection. So you can see within this image here that we've got the instrument with the software actually on the instrument, and we've got this simple one cable connection to the tool. So this tool is mechanically applied to the pipe using a simple torque wrench, and you can see it's very easy to set up, very quick. And within the corrosion under pipe supports, what we're particularly looking at is small diameter pipes. So these are pipes ranging from 1.5 inch all the way through to 4 inch, 6 and 8 inch as well. For the 6 and 8 inch, you might go to a crawler, and there's always, but where we have the potential advantage is where access is difficult. So for example, here you could see if you were going to use a circumferential crawler in this case, it would be difficult to get between the two pipes, particularly as it's a clamp, so you couldn't run across the top. So what we're doing here in this particular example is we're actually using putting the tool on here about 1.5, maybe 2 meters away from the pipe support, and we're actually firing the sound into the pipe support, and then we're looking for a response. So we're mainly targeting small diameter pipes because obviously the collar's low profile, and we're also targeting non-welded pipe supports because those types of pipe supports don't usually give us a response, and so therefore we can. And what we have with the higher frequency version is a much better sensitivity. So for example, we found defects of the order of 6 millimeter diameter, 50% through wall on a 4 inch pipe. So we're looking at 1% in what we describe as sensitivity in terms of guided waves. We're looking at 1% cross-sectional area type defects with this type of setup. And we have actually got experience of believing that could actually go further down as well to significantly less than that. So we feel that on the smaller diameter pipe supports and smaller diameter pipes generally have probably been neglected somewhat, and guided waves using the magnetostriction has definitely got a very good option at being able to sort that out. So if we move to the next slide, you can see here the types of responses you can get. So you can see here from these scans, when we've got no defect there, we've got really excellent signal to noise, is practically zero. And then as you build a defect into that pipe and grow the defect, you can see it also growing. And from the C-scan imaging, you can see you also get very good angular position. And by using our phased array focusing method, you can get even more angular data as well of the corrosion. And this is really good because what within the focusing, what you're actually looking at is differences in responses around the axis of the pipe. So you're comparing the amplitude you get at the top of the pipe to 45 to 90 around the pipe, and you're looking at changes in responses circumferentially, and that's really valuable when it comes to pipe supports. So essentially, if I could summarize on the medium range method, then it does show really promising technique for small diameter, so 8-inch and below. It is still a screening tool. Sadly, there's still, it's a guided wave technique, so it's not going to be able to provide you with minimum remaining wall thickness. But what it will be able to do is, compared to using a long range ultrasonic method, the sensitivity is significantly improved if you go for this procedure where you're targeting the inspection. So you're targeting each pipe support individually rather than lots of pipe supports over a range. It's very quick to deploy, quick data collection. It doesn't require that much. It's very simple method because you're basically, calibrating off a feature beyond the pipe support, and then you're looking at amplitude and circumferential resolution, if you like, at the pipe support. So it's very straightforward and very simple to do. So that basically, I think, concludes what we want to say regarding both the phased array methods and the medium range methods. So Gareth and I would be very pleased to hear if anybody's got any questions, unless you've got anything else to add, Gareth.
No, nothing really. I think you've summed it up. Again, I just wanted to take the time to show you what Eddyfi Technologies had as solutions for cups, and especially considering, I suppose from the phased array UT side, if you've already got your phased array instrument, then and a sort of a link scanner, then there's only a small amount of additional equipment that you would require to be able to as a sort of an entry into providing a cup service.
Yep, good. Okay, so any questions? Okay, the first question:
Well,
how many pipe supports would you expect to scan per shift with the Sonics? It's always difficult to talk about this because there are so many other factors into play. But if we consider that, should we say the pipe support's fairly accessible? So it's a nice simple pipe, nice waist height, easy access between the two where you can walk between the two. We would be looking at no more than 10 minutes per pipe support. So we'd be looking at about 6 pipe supports per day. So of the order of about 40 or 50 in a typical shift would be what we would probably be quoting the job on.
Depending on how many coffee breaks you took.
Absolutely. And how long they were.
What version of the link scanner do you need for this application? So as standard, the Lynx Full comes with corrosion mapping and weld inspection capability. It's just a bolt-on pack called the complex kit that you require, and as I said, it gives the customer the ability to reconfigure that advanced sort of modular scanner to be able to perform cups. Yeah, just relating to Lynx itself. Yeah. And when you mentioned using phased array sectorial imported, so the third-party software. So there's 2 third-party sort of companies that that can accept the data sets that are exported off the instrumentation at the moment. I say it is really dependent on what your what the not so much the damage mechanism is, but some of the limitations in terms of the kit and what the expected outcome is. I would recommend if you get in touch with us, our emails will be our email addresses will be there at the bottom of the screen at the end of the coffee break, and we can chat at length to which would be more suitable for your application or testing. And pipe supports for MSkip. So I'd say around 2 to 3 per hour, depending on again, same as what as Paul explained, ease of access, location. You got the equipment setup to consider, but in good conditions, I would say that that 3 to 4 per hour are achievable on pipe supports specifically. If we're looking at more like sort of saddle supports on pressure vessels, I'd say that it is going to take a little longer, depending on the size of the pressure vessels. Some of the pressure vessels could be 5 meters in diameter. So yeah, it may only be down to like almost one pressure vessel per shift in that scenario. What's the probability of detection of the defect? How is this noise to signal ratio? I don't know if you want to talk about the sonics in terms of that first, Paul. And
more work on the probability of detection needs to be done. We're looking for a very good noise floor. Obviously, if you start to get a noisier pipe, you start to reduce the size of the defect you could detect, and so most of the time from our experience, part of the reason why we're going for a shorter length, so a 1.5 to 2 meter running, is because we know that the noise floor is really low, and coating, things like the scatter from the pipe doesn't tend to come into play before it hits the pipe support. So in terms of the probability of detection, we work on the assumption that you still have the 2 to 1 ratio out of the noise, would be what you call, and that's part of the reason I mentioned the 1% cross-sectional area defect is sort of what we're looking at and what we think we can, because we know we could confidently detect that. But if you go below that, it then does start to get to the limits of what the noise from the pipe and how that will interfere with the sensitivity.
And I'd say from like a UT phased array perspective, it'd be aligned to those disciplines themselves. But if you'd like to put your email address into the comments, then certainly I can search for a sort of a more defined answer depending on maybe the wall thickness and the inspection scenario, because as Paul mentioned at the start, often the inspection scenario can determine the factor of what the minimum sort of viable defect is for detection and sizing capabilities. Okay, on to the next one.
No coupling required. Magnetostrictive we have is basically an EMAT and around a magnetic foil, and all of that is housed in the collar itself, which is why it's very low profile and very lightweight. So when you actually what we use is force, mechanical force. So we basically clamp the collar to the pipe. So when we change the current in the EMAT, that induces changes into the magnetic foil, which then induces a sound in the pipe. So we don't need any coupling.
Any more questions like coming through? Okay, thanks, Ali.
Okay.
We'll get back to that. And Arjun, a catalog. If you could be maybe a little bit more specific in terms of the catalog, that would help us out a great deal, just so that we know where to focus the information that we provide to you. That would be great.
Got a question come in. Can you size using medium range UT. At the moment, no, it's a screening tool. So it's very much looking at amplitude, and we're looking at the amplitude of the signal. Usually, and this is part of the reason why we're particularly targeting small diameter pipe, because generally we consider it has been neglected. X-ray is probably the most common use, but what they generally after doing is finding whether something's there or not. And then in small diameter pipe, it's much easier to lift than some of the larger, particularly if it's welded type pipe and pressure vessels that Gareth talked about as well. So sizing can't be done using the medium range UT. It's based on amplitude. Obviously, what we can do is we can give you some circumferential extent, and that will be indicative in terms of how severe the corrosion is likely to be and how localized it is. And you could also do things like comparing. So you could prioritize based on circumferential extent and size, so that you can then say, well, let's target this pipe support first because this is in these attributes, this is the worst one, and therefore likely to be in the worst condition. So there are lots of things that we can do in order to be able to give indicative condition.
So the current RMS, if you had, like, say, an RMS crawler that you didn't want to use for corrosion mapping anymore, maybe you purchased two at the start, we put together like an upgrade pack where we can supply the scan and drive enclosure, which I mentioned can be placed into like a switchable magnet box. Also comes with shielded tractor cables to limit any crosstalk, and shielded UT cables. So you would have to sort of almost retire that RMS scan head as a corrosion mapping system, but you can utilize the tractors from it. So yeah.
There was a question regarding QSR1 in terms of comparing the two systems. So the QSR1 is uses an EMAT, and it works in a similar way to one of the inspection methods that Gareth described, where you've got basically pitch catch on the top of a pipe, and it traverses across the top. Now with the links, you could do something similar using the phased array probes going around the circumference. What you've also got for clamp type supports, which you can run over the top, you have the alternative of running the tracks over the side as well. And obviously with the RMS, on a welded type support, you can run across the bottom. So it sort of spans similar applications to what the QSR1. There are limitations to that, but it also covers other applications which the QSR1 doesn't cover, such as the pitch catch on the around the circumference, and certainly on the pressure vessels as well. There's other questions in terms of what kind of pipe supports this system can work. Maybe you may have arrived a little late to the presentation, but we talked about the different pipe supports at the start of the presentation, and what we're looking at is a specific inspection strategy for each pipe support configuration. So, for example, for smaller diameter pipes, particularly if they're racked closer together, we might propose the medium range UT method. For the for the clamp type supports, you'd have to do the pitch catch method. For very large diameter pipes, and for pressure vessels or slug catchers, that type of thing, you'd probably go for the RMS coded approach. So there's different for run-of-the-mill pipe supports, rested pipe supports, sort of that 6-inch to 20-inch range. You probably would then go for the phased array, running the probes across the top type applications. So it very much depends on what the pipe support is in terms of what strategy you would go. And we feel that with the Eddyfi solutions that we're talking about here, we could pretty much target most pipe support configurations and help customers decide what the best equipment would be for that application. Is there any limited thickness range that applies here? For the medium range guided waves, we're looking at small diameter pipe. Usually they're thin walled type pipe. So there's, basically on the minimum thickness side, there isn't any really limits. There is sort of when it starts to get to 1 inch thick, we start to worry. But you're not really going to get a 1 inch thick walled 4-inch pipe, I don't think. Gareth, I think from you were saying 6 millimeters and above you're quite comfortable with.
Yeah, so 6 millimeters and above on the pitch catch phase re methods, and then say around 9 millimeters and above for M-skip. But I think again, a lot of these questions, and just to wrap up on these questions, really is that as the Eddyfi Technologies group, we've got the ability to assist you in terms of what the best solution package is, depending on your issues. The damage mechanisms, the pipe diameters, the pipe wall, etc. And our emails are on the bottom of the screen to be able to facilitate your questions and what solutions are best for you guys. So yeah, thanks very much for joining us. Yeah, and
And thanks for
Paul,
the
I don't know if you want to
interaction.
close out.
It was a really, nice, to have good interaction with the, with the questions at the end. So that's very valuable for us. Thank you.
Thanks very much.